Okay. So it's rare that I give like a shameless plug for a particular program, but this Notability app is what I'm going to be using to grade your papers, and that's what I'm going to use when I lecture. It's one of the coolest things I've seen in terms of like the learning process, because if you're like one of those that has to listen, that you want to be able to listen to a lecture again, this is a cool deal, because if you, it only works with iPads, it doesn't work with like Dell and desktops and things like that. It does work with an iPad, and so if you use this program, there's actually a, you can go up here, and you can't see it very well, but there's a microphone icon up there, and what it will do is it will record the lecture, it will record the auditory portion of the lecture. So if you have an iPad and you're in here and you take notes, and it's recording my voice as well. The cool part about that is that when you get done, then if you go back and you, like, let's say I'm talking about momentum, and you hit that momentum, then it will start playing back that lecture that's associated around just that portion of the word momentum. So I'm not telling you to go out and buy an iPad and download the Notability app. But if I were you all going into like college and things like that, it's a cool deal, because it you know, like, record the lecture and you've got your notes and you have everything all in one place. Okay, just saying. All right, so let me see. Let me make sure I've got this. Nope.
Oh, there's a stack right there.
That's a stack. Okay, so on the calendar, okay, that you have. So that's one of my better organizational skills that I've done. I even color coordinated it like the red, and obviously I didn't print on white ink because that just didn't show up so well. So basically, for the first 2 weeks, let me explain what you have on that calendar. So Wednesdays, everybody's going to be remote starting next week. So between now and, like I said, tomorrow, you need to watch that MKS lecture. I'm just going to email you the link. I'm going to put it out on YouTube. I'll email that to you. Probably, I'm guessing it's going to be about 5 o'clock. Starting on Thursday, and for the foreseeable future, you all have to keep this time log. So what I've done is that I've kind of gone through and estimated how much time you're going to need for this class so that it adds up to 90 minutes. So, yeah, I've got like 2 icons down there, like LT and like homework. So that's just going to form kind of the basis of what you all can write down on that timeline. It's vitally important that you get in the habit of doing this, because your encore teacher is going to have to check it. And, you know. Now, on the homework, I'm guessing, like, for example, it might take you 40 minutes to do the lab. Some of you, it might take an hour to do the lab. It might take you 80 minutes to do the lab. Some of you might get done in 30 minutes. Don't flip out on that, okay? What that's going to allow you to do is at least have a working basis of that. Now, in reality, if you do the lab and it takes you, an hour to do that, hey, maybe that, if you're short on another class, maybe that'll allow you to make that up. But here's what's going to be so important, because I have to get through this material. Here at the beginning, yes, I'm giving this lecture to you guys, and then tomorrow I'm giving the same lecture to the end of the alphabet, to the other group, okay? But from here on out, that's not going to happen. So if you're here, you're going to get the lecture. If you're remotely, it's going to be your responsibility to get that lecture and to get that home. So I will try and give you like the paper copies of lecture notes and labs and things like that. Because I know some of you might not have printers, and that becomes an issue. So at least because I will see you guys every other day, at least I'm going to have the opportunity to give you the paper copies of the things, so that you don't have to worry about printing them out. There is like Google Classroom. It's a pain. I don't like it. I might put some basic stuff in there, but at least here at the beginning, until I see how this whole deal is going to play out, I'm really not going to put anything in Google Classroom. I'll email you the links to the YouTube. I'll email you the assignments because, like I said, you all are going to send them to me as an attachment. I'm going to grade them. I'm going to store them, and then I'll send them back to you. Okay? So right now, that's how I think it's going to play. That's subject to change, even though I've taught for 30 years, and I usually have my Scooby snacks in a row. In terms of the content, I'm good, but you know, it's like, oh, do I record it on Zoom? Do I record it using the camera? How do I upload it to YouTube? You know, do I let you in on the Zoom meeting? Do I send, anyway. So, at times, you're gonna have to bear with an old dinosaur in terms of, you know, how this plays out. So, the cool thing about the study of physics is that it deals with extremes, okay? So I haven't taught for 30 years. I've had kids that have gone on to study different aspects of science. So one cup here, this is from the Jet Propulsion Lab out in Pasadena, California. And the Jet Propulsion Lab is kind of like a branch of NASA. So NASA comes up with the big ideas and they give it to the Jet Propulsion Lab and go, here, make it work. And that's kind of their idea. So Michael Staub, one of my former students, was working out there at the Jet Propulsion Lab. And if you remember, this is about 3 or 4 years ago, there was the Cassini space probe that was orbiting Saturn. Okay, it's a wonderful, successful mission. If you ever get bored, just do a simple Google search of the Cassini mission. So Michael is what's known, he was known as the mission ace. So he sat at the controls and monitored, this was his job for 3 or 4 years, was he sat there and he monitored the data that was coming in from the Cassini probe. Trajectory, you know, the magnetic field, all of these things. And it was kind of cool because when they had like the end of mission, they crashed Cassini into the surface of Saturn because it was afraid it might hit one of the moons and then introduce microbes into the moons, and we didn't want that. And so it's like, oh, screw it, we'll just crash it and run it. Done, there you go. And so he was the one like sent like the last messages to the Cassini spacecraft. So you have a branch of physics which is going to be dealing with the very large aspects of our universe. Like, okay, hey, what's the mass of the sun? That's a good question. You know, what's the mass of the Milky Way galaxy? You know, what's the mass of the universe? How are things moving in the universe? So you have a branch of physics that is dealing with the extremely large, okay? Now, the other side of that, I also had a student, Reed Bowles, who did an internship at Fermilab up in Chicago. Fermilab was the first big particle accelerator in the United States. And so the Fermilab is dealing with the fundamental building blocks of nature. So, you know, like in chemistry, you all learned about the protons, the electrons, and the neutrons, right? What the Fermilab is trying to do is they're trying to figure out what's happening inside the proton, or what's happening inside the neutron. What are those particles made of? And you get into quarks and things like that. And so you have a branch of science that is dealing with the extremely small as well. Okay, like what are protons made of? Oh, protons are made up of quarks. Well, what are quarks made out of? And so it's like you start down this rabbit hole of like, okay, smaller and smaller and smaller particles, and that's what we're trying to figure out. And so when we get to that, I'll tell you the VW bug story about how physicists approach what a VW bug is made of. It's a good story. So what I'm going to teach you is kind of like the macro, especially in this first 9 weeks, excuse me, the first 18 weeks. It's kind of like the big picture. So we're going to get through kind of page 1 out of a 1,000-page novel that makes up physics. So we're going to study, kind of lay out this groundwork of the tools that you need. Because to do physics, there's kind of a special skill set that you need. So it's kind of like, you know, Ryan knows that the water pump is out on his car. Okay, great, water pump is out. But if he doesn't have the wrenches and screwdrivers and everything else to fix that, then knowing that the water pump is out doesn't do any good. So the same thing is true of physics. Okay, you all understand physics. You get the idea, oh, there's gravity. Okay, great. Gravity makes things accelerate. So one of the words that I hate that I banish you from using is the word decelerate. Okay, it just confuses you. Okay, so one of the things that do not say, oh, things are decelerating, I will flip out. Okay, and here's the reason why. Because in the back of the room, there's this big sign. Diego, you have to take my word for it. That says F equals MA. Okay, so in the back we've got the pen that doesn't write. There we go. F equals MA. Okay, this is like the mother of all physics equations. It's Newton's second law of motion. Force equals mass times acceleration. So you all, get the idea that, oh, here's your force. This is how much that you have to apply. Here's your mass, here's your acceleration. So if I have a small magnet, or if I have Hank the bowling ball, the magnet has less mass, boom, it's not going to take as much force to get it to accelerate. And the reason that I don't want you to use the word decelerate is because there isn't another version of that equation that says force equals mass times deceleration, okay? The only way this equation exists is force equals mass times acceleration. So acceleration is just a change in your velocity. And you actually have three ways to make your car change velocity. You have your gas pedal, which makes you speed up. You have your brake, which makes your velocity vectors get smaller. And then you have your steering wheel, which changes the direction of your velocity vectors. So there's actually three ways that you can accelerate your car. So this is why I get hung up when kids start to say the word decelerate. It just gets confusing, okay? So if you want to irritate me, go, oh, Mr. Burkamp, I hit the brakes and it decelerated. No, stop, don't, okay? And I always get kids on Twitter or whatever, they'll message me, oh my God, Burkamp, I'm at a physics lecture in college and they're using the word decelerate. It's like, no, and they just want to stand up and scream and go, stop, don't. Okay? So, anyway, so on my list of things that annoy me, don't use the word decelerate. It's just bad things that happen. Okay, we're in the home stretch. Take one last chance to stand up, stretch your legs, and then we'll get through the rest of it and we'll be good. So, stop that.